Welcome to Supplemental Learning Modules for MET 120 and Old Dominion University. You're about to learn something about assembly drawings, something about explode state, and a bill of materials. So first of all, it's important to understand what is the difference in between assembly drawings and in between the detailed drawing. Assembly drawings should show you how individual parts should be assembled in order to make a sub-assembly, assembly or on a bigger scale a machine. And they do not normally show size, and more importantly, they will show you where is the location of each part in assembly. And a detailed drawing is a drawing of an individual part, which includes all dimensions and all orthographic projections. So remember, for assembly drawing, you shouldn't specify the size, and there's no dimensioning in assembly drawing. And there is another rule of thumb, standard parts do not need to be drawn in assembly drawings. You would only specify it in a bill of materials, which is the table in which you will add all your parts with their quantities. So you should put a standard name of the part and the standard by which you can go in order and purchase the part. So if you have any kinds of bolts, nuts, you don't have to necessarily draw them in assembly drawing. Another rule of thumb for successful creation of bill of material, which is the list of all the parts that you will have in your assembly, is that drawings included in a working drawing package should be presented in the following order. And also it's important to know before you start creating bill of material, sometimes it fits to the first sheet, sometimes it does not. So one rule is to have first your assembly drawing, so it will be the overall structure what you expect to have there. So it should be usually the first sheet, and then go, so it might be maybe 100, and then the part number might be 1.01, and then the part number 2 might be 1.02, and so on. So if you have less than 100 part, you might use two spaces. If you have more than 100 part, you might use maybe 1.000 and then 1.001 and so on. And then at the end, you should add the standard part sheet at the last sheet. So you don't have to draw them. You have to list them, what are the standard parts that you will need for this assembly. So one example of standard parts in assembly showed here. For example, if you have compression spring, you might say that the diameter is 8, the length is 46. It's 0.4 wires, it has 12 coils, this kind of steel, and you need one for that. And then for another part number 11, you will have a screw, for example, metric screw, 8 millimeters, and step in between two different will be 1.25, and it will be hexagonal head cap screw, and the length will be 30 millimeters. Material will be brass, and you will need 4 of these in your assembly. And then the part number 10 will be the plain washer, and those will be dimensions in millimeters. And the material will be this kind of steel, and you'll need one. So it's all information that you need to purchase this item. And the part number 12, in this case, will be the spring pin, diameter 2, length is 14, double size, and you need one. So this is example of one assembly drawing. As you can see, you can have multiple views, as many as you need, because some assemblies might be fairly complicated. So you see in this one, they have even different cross sections, and they want to show you what exactly do you have in each one of these views. So we have section AA, we have section BB, we have section CC, we have section DD, and then section EE. So there are many of these because there's so many different details that you will need to see. And this one was drawn before computer-aided design. This other example will show you explode state. Explode states are very important for assembly, and you would very commonly see something like this. Because if you would need to assemble all of these parts, it's so easy to understand when you put them all a little bit apart. So it's important that you keep still these axes that you would have in the final assembly, but you can still see what is their mutual relationships. And sometimes you might even see the lines which are connecting some of these parts. And this list here is bill of materials. So we have the item number. Usually it's going from bottom to top, but you might see these ones from top to bottom. And then you have the part number, and then you have the title, and then you have the quantity. And it gives you some overview of how many parts you really need to have this assembly happening. And this is another explode state with a little bit more complicated part where you have electrical and mechanical components. And you can also see today with the modern computer-aided design, you might even see the cutaway assembly drawing. For example, here you have the engine. This is a little bit more artistical ones, but nowadays the companies are trying to be current and use the 3D designs and show you some kind of cutaways. And then here you can have different sub-assemblies, and you can again have here the bill of materials. You have items, item number 1, 2, 3, 4. So we will see that number 1 is the body of this carburetor, and then you can see what is the so we need only one, and then you can see the O-ring is number 2, so it's here. You see this black over here, and so on. So you will see each exactly. For example, number 4 will be the fuel feed nipple here, and then also on the other subassembly you will have another items. Here you have only 5 in this subassembly. So for example, number 1 is the piston, number 2 is the gudgeon pin, and so on. And here in the big one, you have more parts. You have 21 parts. And for example, if you see the part number 20, here you have the standard, because this is the hexagon socket head cap screw. And you can see we need 6 of these to have this assembly happening. So these are the screws that you will see here. And this is another example of assembly, and you might see how the 3D assembly might look like. And here on the left, you might see different kinds of parts. And what it's important to understand in Inventor, that would be the software that you will learn in MET 240, you can generate assembly drawings from existing three-dimensional assembly file, so you will not have to do all lines from the beginning. You will retrieve the design you have, and then from them you can create assembly drawing. So for example, it will look like this. You see we have this kind of design, and we will show different views, and we can show the broken views if it's too long, and then you can put the ISO view and different kinds of things. So this is the basics about assembly drawing that I want to show you. And the last thing is to show you again in the bill of materials, a little bit different terminology. So balloons are these circles with numbers, and they will match whatever you have here on the parts list. So if it's number 1 here, it will be the body. It will be the number 1 over there. And you can also put there the mass, material, and you can put many different properties, whatever it's needed. And then you can also use some lines to, for example, if I have all these screws here, bolts, and I would like to put them here in the hole, so I can add axis of assembly. So it's important to know what are the balloons, what is the bill of material or part list, and how it's going to be located in the part. And very commonly you will have the first assembly drawing together with the bill of materials.